All right, let's see. Hey, 2 red dots. I'm guessing I need to say something before we work on the examples. I'm guessing. What do you think, Larness? I think so. Let's tap it and see what happens.
Wow.
You know, just give me a smartboard. I need nothing else. No movies, no books, nothing. Just give me a smartboard. It makes things flash and fade in. I'm happy. All right, example number 4 uses what you know about factoring perfect square trinomials. I remember that. The first term is a perfect square, the last term is a perfect square, and the thing in the middle is the 2 terms multiplied together and doubled. Okay? We talked about that. All right. And the differences of squares. We've talked about that. All right, well, let's see what happens. That's what example 4 uses. Oh, my gosh. Okay. All right, well, first question. Is there anything that I can pull out? Is there anything I can pull out, Lauren, to see? No. All right? There are no variables in common. There are no numbers in common to all of them. How many terms do I have, Cameron? 4. So I know it's not the difference of 2 squares. I know it's not a trinomial that I can factor into 2 binomials. I know that I have to group things. Okay, well, let's try grouping some things. Before I move things around, I always look at the way it is right now. That may not work. It may not work, but it might. That's what I'm going to try first. When I look at this first one, I see that they both have a 4 in them. I'm going to pull that out. And it's going to leave me with p squared minus q squared. Okay. Okay, now that looks like something that I like. Difference of 2 squares, but hang on. It still may not work that way. Let's look at the other one. The other one, they both have an r in them. R times 4q minus r. That's ugly. I know, well, hang on. I know that this first one is 4 times p minus q times p plus q, because that's what happens to a difference of 2 squares. It breaks down into that. Plus r times 4q minus r. Okay. Is there anything I can pull out from these 2 terms? Do they have anything in common? Do they? Bueller. They don't. They don't. No. There is no q. There's a 4q minus r, but there's not a q in both of these. All right. If at first you don't succeed, stop whining and start over. All right? Let's regroup these things. Now wait a minute. Wait a minute. Let's look at that. That's a perfect square. That's a perfect square. Okay. What if I wanted to group these things together? Okay. Well, if I do that, 4p squared minus something, 4q squared, what's here? Minus 4qr. Nice. Nice. What about back here? Plus r squared. Love it. Love it. I could do that. Now, they gave us a hint, right? Here's a perfect square trinomial, or maybe it is. 4p squared minus, well, let's see. This is a perfect square. It's 2q. And that's a perfect square. It's r. So I've got 2q and r. Now wait. That sign's negative, so that means that these would need to be negative if this works. Right, Libby? If it works. Multiply this and this. Thanks, Walker. I get 2qr minus 2qr. And when I double it, that gives me minus 4qr. Is it a perfect square?
Yes.
So now I've got 4p squared minus 2q minus r squared. And we'll pick up from there on the next video.